So the goal of this video is just to walk through the problem, solve them so that you can see how I approach the problem and check your answers before the midterm exam. It may be a little bit hard to read the questions. Again, these are the exact same questions you have on your homework that are still available. So if you want to print this sheet out and work it again with me, you can. So the first thing I would recommend doing when solving these problems is start by writing out your formulas. So we'll have a couple formulas we'll use. So work is equal to force in kilograms times distance or displacement in meters. We'll also be using power. Power is force times displacement divided by time, or work divided by time in minutes. And then the other formula that I gave you that you guys can use is the bike specific. Don't use this for treadmill, only for the bike, and it's for calculating power output. So power on the bike is equal to resistance in kilograms times 6, and this is meters per revolution, times revolution per minute, or RPMs. Okay, so how much total work did AB do starting in this first problem? So AB pedaled at a mean rate of 65 RPMs for 5 minutes with 3 kilograms of resistance. So if we want to use our work equation, we can easily pick out our resistance. So our force is going to be 3 kilograms times our distance. To get our distance, we know they cycled 65 RPMs for 5 minutes. So they did a total of 325 revolutions. And then they did that for 5, and then we know our conversion factor, as seen in this, is 6 meters per revolution. So 325 times 6 gives us 1950 meters. Right? So we can now plug that in. Work is equal to 3 times 1950, which is equal to 5850 kilogram meters. In the next question, we have power output in kilogram meters per minute and watts in the average calories or kcals per minute. So we can do it a couple ways. One, we already have our work, so we could plug that in. We have our work divided by our time in this equation here, or we could use this power equation here. I'll use that one just for question's sake. So power equals resistance, which is 3 times 6 times RPMs, which is 65. 3 times 6 times. And then this would be our kilogram meters per minute. We can check ourselves, right? So we can check ourselves by taking 5850 divided by 5, which would have been this power calculation. Here, using this equation, work divided by time, 5850 divided by 5 minutes gives us 1170 as well. And so we can be pretty confident in that answer. To go to watts, watts is just kilogram meters per minute divided by 6. So we have 1170 divided by 6. Equals 195 watts. And then our kcals per minute, we're going to use this formula here. So kcals 1170 times 0.0023 is 2.691 kcal per minute. Running out of room here. Okay, in question number 2, the person did 47 revolutions in 20 seconds on the bike with a resistance of 4 kilograms. So how much work did we do? So again, we'll start out with work equals force times distance, where our force is 4 kilograms. In this situation, we did 47 revolutions total, so we don't have to solve for RPMs to get in revolutions. So we did 47 revolutions that we know is 6 meters per revolution. 47 times 6 times 4 gives us 28 kilogram meters. And then the same as before, what is this in work? I can do it a couple ways. Again, we can just divide this by time, or we can solve it out and we can put it into our power equation. I'll do that here. Again, I think that's the way most students prefer to do this. So power equals R times 6 times RPM. So our resistance here is 4 kilograms times 6 times RPM. So what I did is I gave you 47 revolutions. 20 seconds is 1/3 of a minute, right? So if they had maintained this output for an entire minute, we would do 47 revolutions in each 20 seconds. So there's 3 parts, 141. So RPM is 141. So we'll multiply that out times 6 times 4 gives us 3384 kilogram meters per minute. In watts, we divide that by 6. Gives us 564 watts. And then in kilogram meters, or kcals per minute, 3384 times 0.0023 is 7.7832 kcal per minute. And you'll notice I'm using lots of decimals. It's probably best to just use 1 or 2 decimal places. I'm not a stickler, but you can keep them short. All right, question number 3. Monarch bike 60 RPMs for 2 minutes with power output set at 110 watts. How much total work did we do? So this one is giving you more information than what you really need. The easiest way to do this is, so we have our 60 RPMs for 2 minutes. That's somewhat irrelevant because I've given you the power output that you need. I know that some students will kind of go through and then solve for the amount of weight that it could do, but we can actually work backwards from our other formula. So 110 watts times 6 gets us into kilogram meters per minute, which is 660 kilogram meters per minute, right? And then we can go back to our formula here, where power equals work divided by time, right? So power equals work divided by time, which we have here is 2 minutes, as you can see. So now to get rid of that, to solve, we multiply both sides by 2. So the work that was done is 660 times 2 gives us 1320 kilogram meters. What was power output expressed as average, or kcals per minute? Again, we have our 110 watts times 6 gets us in kilogram meters per minute is 660. You need that in order to convert into kilocalories. Then we'll multiply that times 0.0023. 15.18 kcal per minute. Sorry, I was like, that seems wrong. So as I was working at it, I go, okay, does this make sense? So here we're working at 110 watts, and here we're working at 564, and we were doing it less. So I missed a decimal place. So 1.58 is the correct answer. So give you an idea of going back and checking your work and make sure that it makes sense, right? So we know 660 should be less than our 564. It wasn't when I first solved it, and then I noticed as I typed in my calculator, missed a decimal, went back and solved the problems. All right, and then last but not least, how much work would they have done in 2 minutes if they had pedaled at 80 RPMs with a power output of 110 watts? So in this case, wattage, the point of this question is just to prove to you that wattage is ultimately independent of RPMs, right? Because increasing RPMs, we would also decrease then the resistance to get to the watts, et cetera here. So we can just solve for this again. So our total work using this formula here. So 110 times 6, 660 meters per minute equals work divided by time. Again, multiply by 2, and you will get the exact same answer as we got before. All right, the last question on this page, you're testing on a Monarch bike with a mean power output of 1050 kilogram meters per minute and a pedaling rate of 50 RPMs. What resistance must you set on the ergometer? So this is where we're going to need this this formula here in order to solve this. We'll work our way through. So our power output is 1050 kilogram meters per minute. And we have a mean pedaling rate of 50 RPMs. We know that our constant is 6 meters per revolution. However, we don't have our resistance in this case. Right, so now we'll just use some simple algebra. 50 times 6 is 300 times resistance. And then to get resistance alone, we need to divide both sides by 300. So 1050 divided by 300 gives us 3.5 kilograms in the resistance file. All right, on page 2, you are testing on a cycle ergometer. You want them to exercise with 4 kilograms of resistance and a mean pedaling rate of 50 RPMs for 3 minutes. The count of revolution shows that they actually pedaled at 47 RPMs. What was the mean target output intended? So power output, again, power equals, in this case, a resistance of 4 times 6 times RPMs of 50. So the intended was 1200. What was the actual? So power equals 4 times 6 times 47. And then what were the absolute and relative difference between target and actual power output values? So the absolute difference between target is 1200, minus 1128 gives us 72. So they had a power output of 72 kilogram meters per minute less than the intended output. To take that into relative terms, the easy way, our absolute divided by our original, or our intended in this case, equals 0.06. We'll multiply that by 100. So 6% less than intended. If we look at work output, the first thing we need to do is calculate work. So intended work is equal to 1200, which is our power output, is equal to work divided by time. Our time here, 3 minutes. So we'll multiply both sides by 3 minutes, as we've done previously. 3600, or 1128. Will give us the same thing, 3884. So what is the absolute? 3600 minus 3384 equals 216. The relative is then our absolute divided by our original, or intended in this case, 3600, gives us 6%. 0.06 times 100 gives us 6%, which makes sense since we're multiplying by the same values that relative does not change. Okay, the last question on the bike. So you're testing on the Monarch ergometer. You want them to exercise at a mean power output of 175 watts for 5 minutes. State 2 different combinations of resistance and pedaling rate you could use to accomplish this. Also, for each combination, what would the total energy output be for 5 minutes of exercise? So when I say total energy, I mean total kcals, which means we need to solve for energy from the work equation. Okay, so if you got lost on this, the idea here is that, again, to drill into the thought that we can use a resistance or an RPM, both of those are going to affect power output. And so in this case, since you don't have either, where do you go? Well, in this case, just make one up, right? So you can pick a resistance or you can pick an RPM and go from there. So we need to be working at 175 watts. So the first thing that we need to get that into is kilogram meters per minute. So we'll multiply that by 6. Is 1050 kilogram meters per minute. Right? Before solving, I'm going to go ahead and multiply this out to get total kilocalories, because the next thing that we'll need to, never mind, I'll come back to that. Okay, so we can plug this into our power equals resistance times 6 times RPM formula, right? So 1050 equals resistance times 6 times RPM. And again, since I didn't give you either one of them, we just need to find the numbers that will make this work. So I'm going to go easy and pick a resistance of 1. So multiply that out, 6 times RPM, multiply both sides by 6, or sorry, divide both sides by 6. So 1050 divided by 6 gives us 175 RPMs. And then we can do the same thing here. We can do it for 2. So 1050 equals 2 times 6 times RPM. So 2 times 6 is 12 times RPM. Divide each side by 12. Gives us an RPM equal to 87.5. RPM 87.5, resistance of 2, and here RPM of 175 with a resistance of 1. So now we need total calories for this. What we need to do is take this power output, convert it to work, and then work into calories. So we have, again, our power equals work divided by time formula, where our power equals 1050 equals work divided by our time, which is 5 minutes from the question. So here we'll multiply both sides by 5. So 1050 times 5 gives us 5250 kilogram meters. Then to get that into kcals, we multiply by 0.0023 equals 12.075 kcals. All right, so last but not least, we will cover some treadmill questions. So I think I've given you everything you need to know. I gave you weight in kilograms, so you don't have to convert there, but we are going to have to convert our miles per hour into meters per minute in order to solve for that. We're going to use the same equations. So work equals force times distance. Power equals work divided by time. So we're going to use those exact same equations, and we'll work through these. So a person who weighs 65.9 kilograms walked for 10 minutes on a treadmill at 3 combinations of speed and grade: 3.5 miles per hour, 5%, 4 miles an hour, 0%, 4.5 minus 5% grade. What was the work output in kilogram meters and calories for each of these walking on a treadmill, considering only the work involved in vertical? Remember, that's one of the downsides of the treadmills. We can only use the vertical. We have to ignore the horizontal. Okay, so the first I suggest doing is converting these miles per hour into meters per minute. So 3.5, 4, and 4.5 miles per hour. To get that into meters per minute, 1 mile per hour is 26.82. So 3, all we do is multiply. So first one, 93.87 meters per minute. Second, 107.28. And the third one, 120.69. Okay, so now we can move into A here, which is they walked at 93.87 meters per minute at a 5% grade. All right, so our work is equal to our force times our distance. We have our force, which is body weight. And now we need to get our distance. So they traveled 93.87 meters per minute. They did that for, let's see, 10 minutes. Which gives us 938.7. In this case, they covered meters. But this is in the horizontal component. To get this into how far they traveled, remember we need to multiply it by the percent grade in a percentage. So 5% grade would equal to 0.05. So 938.7 times 0.05 46.9 meters in the vertical component. So now we can plug that in back to our formula. Work equals 65.9 times our distance, 46.9 gives us 3,093 kilogram meters. And then for total calories or kcals alone, we just multiply that by our constant 0.0023 equals to 7.11 kcals. In B, our work is equal to our force times our distance. We can go through this exact same calculation, 65.9 times, in this case, 107.28 times 10 minutes times our percent grade in this case, which is 0. I'll do the math for you. 0 times anything is equal to 0. Therefore, we do 0 work and 0 kcals according to the equations, which obviously is just physics, not x-phys, because we know it's work. So in the other one, force times distance, force is equal to 65.9 times, in this case, 120.69 times 10 minutes times negative 0.05. And you'll notice I just kind of consolidated in that first answer. I worked it out and kind of worked you step by step, but you really can't just consolidate it just to multiply it all the way across. So 120, multiply those first, 0.69 times 10 times 0.05 gives us, because that's a negative, then we have negative 60.34 or 35 meters in the vertical component times 65.9 gives us negative 3976.7 kilogram meters. And then to get that into kcals, multiply that number 0.0023 gives equals 9.14 kcals. All right, in the next question, I walked on a treadmill 60 minutes at 90 meters per minute at 8% grade. While another person who weighed the same ran on a treadmill for 20 minutes, 275 meters per minute at 8% grade. Considering only the work in the vertical movement, calculate the amount of work done by each subject and who burned more calories. So here, no conversions, everything is already done for you. So work equals force times distance. So work equals 80 times 90 meters per minute times 60 minutes times 8% grade. So I'll start in the parentheses, 90 times 60 times 0.08 is 432 times 80 is 34,560 kilogram meters. The second one is 80 times 275 times 20 minutes times that 8% grade. So multiply it out again. 275 times 20 times 0.08 is 440 times our body weight is 35,200 kilogram meters. So that's how much work they did by each of the subjects. And then B is who burned more calories. So we can already look at it and know, but we'll go ahead and calculate the calories. So for part B, so the first person was 34 34,560 times 0.0023 gives us 79.5 kcals. And the second person, 35,200 times 0.0023 gives us 80.96 kcals. So second person, or QR. So QR burned more calories. Not by much, but burned more. Right, and then the last two are short and sweet. Circle the best answer. 120 watts is equal to, in this case, we multiply by 6, and it gives us in kilogram meters per minute. So D. And the last, fill in the blank. When running a 3% grade, a person's body should move a vertical distance of blank meters for every 1,000 meters horizontal distance moved. So the idea is, remember, 3% is equal to 3 meters per 100 in the horizontal. So to calculate this, all we have to do is do 1,000 meters times 0.03 gives us 30. The answer is 30.